This is Dan Allford, and you're listening to Dan's Cadre of Experts. On this podcast, we've got a special guest, Warren Hankammer. We've known each other so long we can't even remember where we met. Warren, thanks for coming on today.
My pleasure.
All right, so we're both old welding guys, and very different paths through life, but we keep intersecting back and forth. So start out with your bio. What is your backstory? Why are you here?
I was born as a military brat. We moved so often, I was afraid to go to summer camp for fear my parents wouldn't be there when I got back.
What year?
I was born in 51.
51, okay.
I knew from about the 8th grade on that I wanted to be an engineer, but my desires were to be an aeronautical engineer. I was an Air Force brat, wanted to be an aeronautical engineer, and design the latest and greatest fighter airplanes for the Air Force. That was my plan all the way up until college. Okay. And I started in college, and I had to take a welding familiarization course.
This is LeTourneau.
This is LeTourneau.
Longview, Texas.
Oh, yeah.
R.G. LeTourneau's college that he built.
He and his wife founded the college because they wanted a technical school. R.G.'s kind of thought was want to prepare engineers.
For his own company. Somewhat selfish, but
primarily for his own company. But if they went to work somewhere else, that was okay. But when he started, they had to work in the plant so many hours, and so it was a practical application school from the beginning, and that appealed to me. Had to take a welding familiarization course, and there is something that makes metals heat treatable called allotropy. And I thought allotropy was the next best thing since Christ himself. I honestly did. And I'm going, that is what I want to devote my life to is this steel and fabricating it. And so I changed my major to welding engineering. I tell people now that that's a metallurgist with a fabricating background. And
sort of a practical
thing.
Approach.
And so managed to cram 4-year education into 5, was recruited by a company called Airco, which used to be Air Reduction Sales Company, and they were one of 2 companies that founded a lot of the processes we use.
One of the big innovators, and now they're gone.
Now they're gone. They're swallowed up.
As I recall, they're the ones that had the original patent on pulsed MIG.
Yes, and it was a pulsed constant voltage on a constant current background, which means that they heated the metal up in the background with a constant current, and then they would pulse a constant voltage, which gives you a way to melt wire. And they did that, and that was their stuff. But because they don't have the electronics they have today, everything was based on 60 cycles or a multiple of 60 cycles.
Right.
And that's all they could do because we hadn't had solid-state electronics that we have today that change all of that.
Precisely. So I tell people that pulsed welding is kind of like driving a nail. You can't push a nail in, but with repeated impacts, you can drive a nail in, and that's what pulsed MIG does for us, right?
Yes. There's typically only so many ways to transfer metal across an arc. You can spray it across the arc. You make so much current that you propel little droplets across the arc. There's the short circuiting where you touch the wire, short circuits, and because the machine's trying to maintain a voltage, amps go way up and it melts off the end, and that's called short circuit transfer. Then there's globular where there's not a consistent current and it propels drops bigger than the diameter of the wire. And then there's buried arc, and there's some other things. But basically, we want to either spray or pulse. We want to either spray or short circuit.
I agree.
Pulsing allows you to get a spray at a lower average current because you're getting it in high energy pulses. So you can pulse into a spray, and spray is usually too fluid to just weld out of position. But
anything other than flat.
Yeah, and so when you get this pulse, it sprays, then it cools off. So it doesn't fall out of its puddle if you're going uphill or overhead or whatever.
Melt and freeze 60 times a second.
Yep, or 120.
Right. 120 times a second. Yeah, so that's quite an innovation. And it's ironic, but in our shop right now, we have a pulsed spray robot that's welding HY100 material. And the reason we went pulsed spray is because we're having to weld out of position. We're welding vertical up. And so there really would be no alternative to pulsed spray. for this application.
No, there wouldn't be.
So glad y'all innovated.
And yeah, well, I'm glad to have been associated with the company that did that. I didn't innovate anything. I just told people how to use it.
You're part of the history of it, though, and that's why we got you on today. So we got to go back to this this unique characteristic of steel that you like so much, and so it can have a couple of different crystalline structures, right? Is that what you're alluding to?
It's what makes steel's heat treatable, and if you consider a file, and you heat that file up and you cool it real slow, it becomes soft.
Mm-hmm.
Or you heat it up and you dunk it in a tub of water, it becomes so hard that it's brittle, and you can adjust that cooling rate and adjust that heat so that you freeze the metal somewhere between the two properties, and you've locked in a crystalline structure that gives you the properties you want. And to nerds like me, that's just as fascinating as all get out.
That's as close to alchemy as you can get. You can triple the strength of a piece of metal just by heating and cooling it.
If you know how to heat it and cool it correctly, right. Yes.
So you can use a third as much metal. I agree. It's pretty amazing.
Mm-hmm.
A lot of good stuff. So that got you into welding. You got a Laterno welding engineering degree. What year?
1974, should have been 1973, but like I said, hard work and dedication.
And then you went to work for Airco. How long did that last?
It lasted, I want to say 8 years.
What happened?
The man who recruited me out of college, and he said, you're going to have to go to a company-owned store for a while. We need engineering help in the stores, and you need to learn what our ultimate goal is, and that's to sell industrial gases and welding machines. And I went to a store, and I actually learned how to relate to customers and what their needs are during that thing. So it was a profitable 15 months, but my attitude was, I'm an engineer. I don't want to sell stuff.
Right.
Well, I found out if you solve people's problems and you ask them to buy from you, they will. And so that was cool. And then I was a
living example of that.
Oh, absolutely. And then I was a field engineer in Oklahoma, where I would assist the distributors on how to solve problems and ask for business. And the goal was, a distributor can buy from anybody they want to, but to give them an incentive to buy from Airco, who was my employer. They had a distributor in Fort Worth who was pretty big, and they saw that year by year the things they were buying from Airco were diminishing because they were buying off from other places. So my only customer was that distributor for about a year, and developed some good relationships with those people. And after the third or fourth month, they started coming back into the fold from Airco's point of view. And so from there, I became a field engineer for the Houston region. My wife was not happy because we moved to Houston from Fort Worth, and anybody from North Texas will tell you moving to Houston is a bad alternative.
No, I think it's an upgrade.
Well, and you're from Houston, so that's why. But it's the kind of thing that we were here for 15 months. I looked around, and the man that I admired, that recruited me out of college, that made me feel good about working for Airco, got fired. He got fired because he would tell people what he thought. And he was from South Texas, and he would tell them with a good South Texas accent, and he was a bigger-than-life character. His name was Otto Benger, and anybody my age would either love him or hate him if they knew about him. And the powers that be did not like him. He was number one or number two. His territory was either number one or number two in the nation every year, and he still got fired. I looked around and I said, I can understand getting fired for internal political reasons, but how about if I worked for a company for 25 years and got fired for political reasons? Because the only gambling I really do is when I open my mouth in front of bosses. And so that's kind of my personality. Therefore, I said, I need to change just so I can have a variety of experiences to make me more marketable.
Huh.
My wife said, that's a great idea if we could move back to Fort Worth. And so the Studi company said, we don't care where you live. Here's your territory. It's a broad spectrum of places. If you want to move to Fort Worth, we'll even pay for your move.
And Studi's another historic company. It's been bought and sold several times now, but they were some of the innovators on the wear-resistant alloys. That's the way I remember them.
Wear-resistant and corrosion-resistant alloys. One of the Studi brothers, way back in the early 1900s, was reading an article that about machine tools and how you take a piece of steel and you harden it and you grind it to the right shape and you put it in a lathe and it can cut steel. About that time, the Southern California oil was coming on stream,
Right.
and we have rotary cone bits now, but back then it was called a fishtail bit.
A drag bit, single cutting structure.
Absolutely. And so he said, why don't I take powdered metal and put inside a curtain rod, and we can rebuild these fishtail bits.
Literally a curtain rod.
Literally a curtain rod, crimped the ends so the powder wouldn't fall out. And once you started melting it, then it sealed itself. And they rebuilt these oil bits and then ground them to the right shape, and they lasted for a long time.
So the curtain rod provided the steel matrix, and then the powder was the abrasion resistant.
Exactly. And it was a chrome carbide forming deal.
Which was cheap.
Which is cheap. They then figured out tungsten carbide, second hardest thing to diamonds, could be put in here. And they called it borium because they were boring holes in the earth with these bits.
I didn't know that. I've always heard it called tube borium. Now I know.
And because they brought borium to the market and they started making the tungsten carbide, and they made a machine that flung the tungsten carbide against itself, and it would break up, and then they screened the mesh sizes. And oil field loved that. They delivered the first 500 pounds to the Texas oil fields by airplane, their own airplane. They flew it,
right?
Delivered the 500 pounds, made tons of money on the stuff. And tube borium lasted as an exclusive product for them for years and years and years and years.
That's interesting, though. It was one of my first successes at Arc Specialties was replacing tube borium with, which was applied typically with atomic hydrogen or oxyacetylene back in the day. And we replaced it with plasma welders, and I've got them running all over the world. But we still have some tube borium out in the lab.
I believe you made a hard banding machine that did a MIG puddle and dropped tungsten carbide into the puddle.
Oh yeah, no, that's industry standard. That's not my invention. That's something.
I know it's not your invention, but I ran across a few of your machines.
I've got them all over the place. Yeah. I've got them there. Some of the ones I built for Texas are now running in Mexico. They never die. And so, yeah, that's another way you rather than put it in the curtain rod or the tube, you drop it in the molten puddle.
Right, and so that's their claim to fame. Somewhere along the line, somebody says, "You guys make all these wear-resistant stuff. How about you make stainless steel?" And I'm going, same concept. We'll use the small tubes. We'll put an electrode coating on the outside, and we'll make stainless. Well, stainless actually does better if you have a lower temperature. And so these thin-walled steel tubes full of stainless steel powder, and they adjust the chemistry to allow for the carbon steel in the sheath, and then put a thin coating on it. They would run 20 to 30 amps cooler than competing electrodes. Less heat input on stainless, better.
Is that because all the current's carried in the sheath?
Yes. Current density
That's it. Okay.
is the key on that, and the sheath is so much thinner that you don't need near as much current to melt it.
So you get a better deposit, less dilution. I see where you're going with this.
Okay. The next step was somebody said, why can't we put that flux inside that tube? This is before Lincoln came out with Inner Shield.
I see.
They put the flux inside the tube, and they made a continuous wire. It was 7/64 diameter, and they used a lot of it for stainless cladding. Then they made a smaller diameter, and they actually used it for fabrication. They were not interested in going to carbon steel because there's no profit in carbon steel. It's wear resistant.
$1 a pound.
Yeah. Wear resistant, corrosion resistant makes good sense to us. And for years and years and years, that was the method of cladding urea vessels. Take multiple of these self-shielding stainless wires, gang them all together, oscillate them back and forth, and you can control the deposition, you can control the dilution, and in 2 passes you could have a chemistry.
So you start out with an inexpensive steel plate, and then you coat it with a wear-resistant coating because the urea is very corrosive.
Yeah.
Nice.
And because you're controlling the chemistry with powders, you can enrich some of the stuffs to compensate for the dilution. So the used to be the normal thing was 3 passes to get your chemistry. Because they could control their chemistry of their wire with these powders, 2 passes got them the chemistry they needed.
So it's a 30% improvement in productivity.
They, I don't know if they had a patent on the concept of a self-shielding wire, but somewhere along the line, one of the studios that was in charge of the company and Lincoln made an agreement that they could pursue that with carbon steels.
And that's where we get InterShield.
That's where you get InterShield wire.
So you're working for Studi Corporation. Maybe that's where we met. I was working for Hughes Tool up until the early 80s, and we used a lot of Studi.
Oh, yeah. Early 80s was a heyday for the Studi.
Yeah.
We could have met then. It's still my recollection that we met when I was with Jetline.
Oh, probably. Okay, yeah, so you left. Why'd you leave Studi? What?
I got an offer I couldn't refuse.
Local
family-owned distributor in Dallas said, we need a sales manager, and what we really want is a sales and marketing manager. Well, my marketing philosophy has always been, if you solve somebody's problem and ask for an order, they'll buy from you. That's how you built your business.
That's more important than a free lunch?
It is.
Interesting.
They hired me as the sales manager. We had a perfect agreement on the marketing. I was the tech applications guy as well as a sales and marketing manager. And the tech applications we had a bunch of salesmen, and they'd bring me in for technical applications. I was kind of the in-house expert as far as the salesman would market me, and we grew the business.
And this is with Jetline?
This was with Welder Supply in Dallas.
Okay.
Because of our marketing approach, we became Miller Advanced Technical Distributors that very few people could achieve, and we were the only ones in Dallas. Then Jetline approached us and said, would you like to be Jetline Master Distributors, and we'll train you and that kind of stuff. So I was the in-house expert again, but we had several people trained. Our repair people knew how to fix Jetline stuff. Our salesmen knew the basics, and so we were really good with that. Came time for Welder Supply to sell, and I was very proud of the fact that I was the first non-family member to get to own stock, and I'm very proud of that because it was a matter of trust and reward. So I made some good money on that. The people that bought us and I didn't get along, so they paid me more money to go away, and that's when I went to work for Jetline. So my time with Jetline was, if you include the time we were master distributors, was 17 or 18 years.
So Jetline, that's another historic company, one that I've used in all of these companies. I've worked with their equipment. So the Jetline story, give me that one.
Well, it's my contention that we first met when I was with Jetline.
Maybe.
But we may have met earlier, but the first memory I have of you is as a Jetline customer. And
that was once I'd started ARC full time. So that must have been early 90s. Or...
Early 90s, late 80s, somewhere in there.
So Jetline, amazing company, very innovative, California company. Here's my version of it. You can correct me. But they were very good at seamers, which is how you make thin wall tubes. You roll a piece of sheet metal into a tube, and then the Jetline seamers would weld that long seam. And the other thing you guys were very good at was arc length controls. So when you're TIG welding or gas tungsten arc welding, it's critical that you maintain the torch height, and one way to do that is to monitor the arc voltage, and then if it's too high, you move the tungsten down, you servo that axis. And I thought you guys were the best, or one of the innovators on that.
I still say they're one of the best innovators, past tense. They since got bought out, and as people do, they value engineered a lot of the product. Larry Russell was the owner of Jetline Engineering. He was the founder of Jetline Engineering. But his father was the founder of a company called Airline.
I've heard that name.
And so Airline was the predecessor of Jetline. Larry's father founded Airline, and it was primarily for fixturing for aircraft companies. I don't know what the application was that they invented the seamer, but they came up with that. Larry thought he was the heir apparent, and his father sold airline out from under him.
So was not the heir apparent.
Larry didn't have a job. The new owners didn't want him around. He went out and said, okay, jets have replaced reciprocal engines in the airline business, so my company is going to be Jetline, which is better than airline.
Faster.
And so he developed Jetline and later bought airline from the new owners when it was failing.
That happens.
And he said that was the best revenge he ever had.
Yep. Got it at a discount.
He sold Jetline to ITW, which owns Miller Electric, and they merged Jetline under.
That's 10 years ago?
Oh, no, longer than that.
Longer than that,
I can't remember the dates.
And they still exist to this day under that name.
They exist under Jetline. They're under Miller Electric in the reporting structure. So they're an arm of Miller Electric.
I haven't seen a lot of innovation lately, though. Funny how that works.
It's very interesting how ITW is known for Pareto relationships, 80-20.
Yep.
And if you're not careful, you can 20% yourself out of markets.
Well, I've got stories.
and so Jetline still makes good products. They just don't make any new products. When one of the men that I worked for at Jetline after Larry Russell was drawing back was a fellow named Mervyn Roberts. And Mervyn was an Englishman, and it took over a year to get him in to the U.S. legally. I told him he should have just bought a ticket to Mexico and come up. But
yeah, it's a shortcut.
So at any rate, Mervyn would say, we standardize on specialties.
Indeed.
When Mervyn retired, that philosophy went away because ITW is a manufacturing company and they streamline manufacturing. You can't have a lot of specials if you're streamlining manufacturing. And it was time to cut heads. And so they were going to cut somebody in Chicago. And I said, I've got other opportunities. My non-compete stuff with the owners of Welder Supply was about up. So I said, if we can cut a deal on insurance, I'll volunteer to be laid off. And I went to work for another distributor in the Dallas area. Kind of found out he was not as honest as I like to do business.
It happens.
And so I left, and a fellow named Dan Paris and I started a company in Fort Worth called Win Welding Supply. Win came because I came from Welders Supply in Dallas. He came from National Welding Supply in Fort Worth, and we needed a vowel in between, and I sounded really good, so it became Win. And our W was the W of the logo from Welder Supply, and the N was the N from the logo of National Welding Supply.
Sounds like a lawsuit waiting to happen.
Yeah. Well, he had sold to Airgas, and we had sold to another company, and we had identical marketing philosophies. Dan is probably one of the smartest men I've ever met in my life. Dan Paris went to Rice as a freshman, and 5 years later came out as a PhD in material science.
Huh. Underachiever, sounds like.
Yeah, he's an underachiever. He and I started the company. I had the technical stuff. He had business stuff as well as being really brilliant about other things. We brought another guy in named Bob New as our sales guy. Now, Bob is one of the best salesmen. Customers never left Bob, but Bob didn't know he was a salesman. He hated salesmen and was one of the best I've ever met, kind of thing. Dan and his wife are traveling the world now, and Bob is taking pictures all over the country. Great photographer, and I'm the one that's still sometimes working. We took our business from $0 to $4 million a year in 3 years.
Not bad. And
sold to Red Ball Oxygen, who's now still operating the business and doing very well with it.
People.
Very good people. So that all of that was a good transition. I left there went to work for Red Ball after we sold. I left there and went and ran an architectural sheet metal company in Irving, Texas. And my job was to teach the third generation how to take over from the second generation. And that took 4 years. And
Did you succeed?
I succeeded. And when I succeeded, I went into retirement. After 3 months of retirement, my wife said, "You go find something to do or I will kill you." So I started a consulting company. We did some interesting consulting work. Some of it was actually in fabrication, but my first good-sized job in that was to look at a fast food restaurant's menu and figure out how he could make money doing breakfasts. Breakfasts were 12% of his sales. And I said, "I'm a fabricating guy, not a food guy." And he said, no, you're a productivity guy. So they hired me for that. Took about 4 months. And we got rid of a lot of stuff. And, you do a lot of studying and writing and thinking. And every fast food restaurant in the world scrambles eggs. He was doing eggs cooked to order. So we eliminated that. And he had products that were just for one item. And so we eliminated those items. And it came out to just using the same productivity stuff you would look at in a manufacturing business. We got rid of items that were only used for one recipe. We got rid of the specialty cooking because he could use cheaper. Everybody can scramble an egg. Not everybody can flip an egg without breaking the yolk.
Right.
So we got rid of that. We added 10% to his bottom line just for cleaning up the breakfast items in the menu. That gave me a lot of good feeling to say, I'm a productivity guy. I'm not just a welding guy. And so jobs came and went, and that's what a consultant is. I used to say consultant was code for self-unemployed, but it's
that's what I refer to myself as.
Yeah, and so I learned that no, you get as employed as much as you want to, and so I have evolved to technical sales representative for people I respect. It's only 2 companies. Yours is one of them.
I appreciate that. And then you're representing a competing company too. How is that?
Well, I divide it up into.
You're welcome to say their name.
It's MIT USA, which stands for Made in the USA.
Good people.
Very good
equipment.
people.
I appreciate good competitors, by the way.
Well, see, I don't think of you as competitors.
Different segments.
Different segment. And actually I see if it's straight line or just round, it's them. If it's anything else, it's you.
Right. If it doesn't require a computer, you probably ought to leave us out of it.
Oh, yeah. First big job I've done with you was 4 different processes and 1 piece of equipment. It was...
Which was this?
This was for Doosan.
Oh, right.
It was...
turbines.
Yeah, and they did the rebuild turbines.
It was narrow gap. It was TIG. It was plasma, powder, and wire. Yeah.
It was a bunch of processes, 1 control deal. They absolutely loved it.
And that's remarkable. A lot of times these multiple process machines end up getting used for 1 process. So.
Well, I don't even know. They didn't even have a job for it when they bought it. It was bought so that they could tell everybody we can do anything.
It turned out it worked. Good for them.
And their competitor, Siemens, had a similar machine. And they just said, we can do anything Siemens can do. And that's why they bought it. So they could say, we can do anything Siemens can do.
Good. I love it. I love a happy ending like that.
It was a happy ending. Okay. I don't know if they've ever used it, but I know they've sold jobs because they have it.
Huh. Well, we got them running on all the processes.
Oh, yeah.
So, a guy of your advanced age, you've had a lot of birthdays.
I will be 72 in November.
Okay, so when are you going to retire?
When I can't physically do it.
Okay, good for you. You inspire me.
One of the things that ancient Israelis, ancient Jews, when the father was ready to turn the business over to the son, and in ancient times, the business was probably agriculture. When he was ready to turn the business over to the son, he would go sit in the gates. Well, sitting in the gates wasn't same as sitting on your porch in a rocking chair. Sitting in the gates meant he was giving back to the society. The gates is where they had trials. The gates is where they had, if people were going to witness or register a transaction, the gates were where everything happened. And so the man sitting in the gates was giving back to the community. And so as I've cut back, I've been, I tell everybody I'm semi-retired, and the amount of semi varies from project to project and time to time. But the times that I have left over, I try to give back to my area in the Dallas-Fort Worth area. I mentor people. My wife and I do some premarital counseling through our church, and so it's a time for us to give back. The other thing we do is in our free time is all through our normal working life. She was a school teacher, and I'm an engineer. Is we would put logs on the pile for retirement. And it's the time of the year we have enough logs that we can travel, and we really enjoy travel. So every year we take a major trip.
So all you youngsters out there, save a few of those dollars you're making.
Put logs in the pile for retirement.
Absolutely. Yeah. So do you regret getting into welding? Has it been good? Would you recommend it for a youngster that might be listening to our podcast?
There was a Saturday Night Live skit, and the baseball player would say, "Baseball has been very, very,
Very
good
good to
me." I tell everybody, welding has been very, very good to me.
I'm in the same boat. I wouldn't have missed it for the world.
Well, and I still get to do with allotropy. I still get to deal with allotropy. So I can't conceive of me doing anything else. You and I were talking last night, and welding processes have not changed.
And so I've been doing this for 40 years. You've been a little bit longer, and there hasn't been a new process invented in our careers.
No. Now, computers have helped us optimize processes. We had short circuit transfer. Computers have now, both Miller and Lincoln and ESAB and all the people that make machines that are sold here in the U.S. have optimized that short circuit so that it's really, really better than what we had in the late 60s, early 70s when I got started.
And you're no longer limited to 60 hertz on the pulse meg. We can pick a frequency, we can generate it.
And it used to be constant current with pulsing a constant voltage, and now it can be anything combination we want. You think about it, watts do the work.
Right.
Watts always do the work.
Amp volts.
But we can change the amp volt relationship instantaneously now at any frequency we want. But it hasn't changed the process. It's optimized the process.
I got a kick out of it. Everybody's getting into what they call additive manufacturing, and that is what we call welding. And so I'm working with some folks on it. They've been digging, some young people, bright guys, but they've been digging up some old articles, and this has been going on forever. In fact, it was called weld building early on. So once again, none of this is new, but with advanced motion control and advanced computer technology, we can tackle stuff that we've never done before. That's the fun part for me.
Oh, and additive manufacturing is a new fancy term, and there used to be something called dabber TIG.
Oh, I remember it.
And dabber TIG was a TIG arc that would pulse the wire and pulse the arc.
Right. In sequence. I mean, they were synchronized, right?
They were synchronized. And not only would the wire pulse, but it would retract a little bit so that you had better control. We now do the same thing with a laser and a wire feeder. Mm-hmm. We coordinate that. So it's the heat source has changed, but the process hasn't changed. We used to do TIG with tungsten and some sort of shielding gas and some sort of wire. We now do the same thing with standard gas tungsten arc, plasma, and laser. That just changed the heat source.
Right, just different heat source. Same, yeah. Don't get us wrong. There's still plenty of challenges out there, and we're tackling projects we could never do before. So I eagerly look for projects that we're unable to do, and when technology allows us to handle it, we tackle them.
Yeah, we used to bend metal by heat or straighten metal by heat.
With an open flame.
With an open flame. Now you do it with computers and induction heating, but it's the same mechanics.
In a tenth the time with better accuracy.
There you go.
But it's the same phenomenon of, they typically call it heat straightening, but we do heat forming. But I was taught by Jeff Post, a mutual friend of ours. He's gone ahead of us now, but he taught me, and before him it was Ray Stitt taught him. And so I'm third generation. Mm-hmm. So it's an ancient technology, but if you apply robots and induction, it can do magic.
I have always said that what we do is a mixture of art and science. Your job and my job has always been, let's apply the science so it can be repeatable and faster.
Mm-hmm.
That's basically what our jobs have always been. You're the guy who builds the equipment, and I'm the guy who applies the equipment, but it's the same job. Let's take that art and apply the science.
So what you have to do as you go through life is you look for problems that are seemingly unique, but you've actually solved them in an entirely different arena. And so what you're doing is reapplying an old solution. Makes you look smart, but in reality, you've done something very similar in a different area. It's called analogous thinking. I'm all in.
You just modify for their background, their circumstance.
Mm-hmm. And reapply it in a new industry and change the world. So let's talk about the Welding Society. This is something I'm talking to you youngsters out there in the audience. I'm a huge fan of professional societies, and AWS, American Welding Society, is one of them. Are you a life member?
I am a life member.
So am I. That's 35 years, right?
I don't remember. I've been a life member so long I don't even remember. I do remember that I started my freshman year of college, and I began my freshman year of college in 1969, the fall of 1969. So I've been a member since then. I started off as a student member, became a life member, was very active in my local chapter for a long time. Never did any committee work because I was too busy solving the problems of the rest of the world. But I'm a big believer in that. The American Welding Society is responsible for the entire world's welding accumulated knowledge. There's two organizations, ASME and AWS, that really control how we build things.
Thankfully, that's through voluntary codes and specs rather than government intervention.
The government would screw it up.
Indeed.
And the government wouldn't mean to screw it up. They just try to cover everything. And the American Welding Society and ASME both are made up of people who actually do the stuff.
What a concept.
What a concept. And so between those two organizations, we know how to qualify welders. We know what procedures are there. The big thing of the AWS is it's got codes for everything, but the AWS structural code
T1.1
is got pre-qualified procedures.
Because some processes are so reliable that there's no need to spend money on additional testing as long as you follow proper industrial practices.
Right.
I love that.
And you know, it's most other countries that do manufacturing that worry about having some standardizations will adopt their codes from American codes.
Why not? It's working.
The Germans probably have the second best code system. 90% of it's a direct copy, you know, and I pull that number out of the air. It may be a little more, maybe a little less, but majority of it's a direct copy of the AWS codes, translated into German.
It's a great organization. If you're not a member, you should be. I know when I just got out of school, I was making $7 an hour, and I couldn't even afford the meals at these professional meetings. So I would kind of sneak in after the meals so I could come in and just hear the tech talk for free. And now that I'm a life member, I get in free. Like, where were they when I needed them? But spend the money. And if you're a student here, at least in the Houston chapter, you eat for free nowadays.
Don't know what it is in the North Texas chapter until about 5 years ago. My schedules haven't worked out, and kind of COVID shut things down and haven't got back in the groove. But student members ate free in North Texas also.
So if you could go back and talk to your younger self, what advice would you give to young Warren?
Actually, I would say don't change a thing, because even the hard times, I learned stuff.
Oh, I'm the same way. I wouldn't trade this life for anything, you know, and I wouldn't want to do it all over again because I'm not sure it would go as well.
I wouldn't want to do it all over again because the hard times, I learned stuff. I already know that stuff. So. But like I said, I wouldn't change a thing. Things usually work out the way they're supposed to in the end. That doesn't mean that the road's smooth. It just means that if you pay attention, you'll learn something and you'll be able to apply it later.
If you don't have bad times, you don't appreciate the good ones.
I totally agree.
So all the struggles are just part of the process. What else did you want to get in on this conversation today? You know what I want to do is I want to get you and Dave Hebel, and I've not had Dave Hebel on the podcast. You and Dave went to school together, right, at LeTourneau?
We were in the same class at LeTourneau. He was the smart one.
Aha.
Dave is so smart that when his last few years with ESOB, everybody called him the professor.
I still do.
Dave is one of the few people who crammed a 4-year education into 4 years. Like I said, it took me 5, but Dave was a 4-year guy.
But then, so when y'all left school, you became competitors. But in our industry, there's always cooperation.
In the early to mid 70s, there were 2 big innovative companies. One was Linde. The other was Airco.
There you were.
I went to Airco. He went to Linde. Linde has a list of patents as high as your knee, and Airco has a list of patents as high as your other knee, but they're in different directions.
Mm-hmm. Well, we got to get the 2 of y'all in the next one and get you to reminisce and contradict each other.
Actually, I don't know that we contradict each other as much as we would complement each other, because we're both applications people. Mm-hmm. His expertise is a little different than my expertise. We have the same foundation and the same fundamentals.
Well, I'm grateful to know the 2 of y'all. It's been fun for the last 30 years or however long we've known each other. So tell you what, why don't we make that a promise? Let's get the 2 of you guys on, and then we'll go through the welding history from 2 different perspectives of the 2 most innovative companies.
I'm up for it.
Thank you for joining us today.
My pleasure.